Okay, as we go through the slides, you'll notice you have possible outcomes for 3 by 3 matrices, so it's the extension of what I said we'll come back to with the 2 by 2. So hold on to that page, and let's go and do some examples. So what does this look like? There's a couple things you're learning on the fly here. We're going to convert these equations to a matrix form. So what does the converted form look like? We just take coefficients in the matrix. Okay, so coefficients or constants only. All right. So this first one, this is what you did in grade 10. You did elimination. You're going to, after this example, say, well, why would I not use elimination? Well, I agree, but I want to start with something you know. So the first equation, so I'm looking at the equation that's highlighted in yellow here. The first equation in a matrix will look like this. 3, -4, -18. The second equation, which is going to be in green for me, is going to look like this. 2, 5, and a 4. Okay, off to the side, what we want is this. We want a 1 and a 0, and then a 1. So this is what we're aiming and doing, okay, in the matrix, and then we'll have a number here, a number, and a number. Okay, so how do we accomplish that? Well, row 1, so I'm looking at my 3. I want to get a 1 there. How do I get a 1 there? I take row 1, and I'm going to multiply by a third. So I'm going to have a new matrix, and there's an equal sign because this matrix is equal to the one above it. I'm going to multiply that whole row by a third, so I end up with 1, -4 thirds, and -6. And the other thing, I did forget one thing here. You'll see you have equal signs in our equations. How do you show that there's equal signs in a matrix? We have a vertical dashed line. That shows that that's an equal sign. Okay, so I didn't do anything to the second equation, so I'm going to leave it as is. So we always work down, okay? So I guess if you want to get steps here off to the side, first step, get A11 to equal 1. Step 2 is to get A row 2-1 equal to A3-1 equal to A4-1 ... equal to 0. So you want to get all the other numbers in that column to equal 0 underneath the 1. So that means that I'm looking at the 2 now. How can I make that a 0? I'm going to take the second row, row 2, and I'm going to subtract twice row 1, because if I take the 2 and I subtract 2 times 1 is 2, so I'm subtracting twice the first row, I can make that a 0. So the first row will not change. We're not doing anything else to it. It's going to stay the same, and that's true for everything, every matrix that we're talking about. So the first one, the second row, then this number 2 here, 2 take away 2 times 1 is 0. Okay, so I did 2 minus 2 times 1. That's equal to 0, so I'm just doing the rough work off to the side. That then means if I go to the next one that I'm looking at, so I'm looking at this one, I'm going to have 5 minus 2 times -4 thirds. So this will take a little bit of work. I know I need a denominator of 3. So the 5 becomes 15 over 3. It becomes adding, and now it's 8 over 3, 2 times 4 thirds. So 15 plus 8, 23 over 3. Okay, so that's what goes in here. 23 over 3. And I'll just erase that now, because it's just rough work. You can scratch it out. And then finally, I will have row 2, so that's 4 minus 2 times row 1, which is our -6. So that's just 4 plus 12, which is equal to 16. So we have 16. And then your final step your next step, I guess, step 3, is to get A22 equal to 1. So in our case here, we need to get this to equal 1, and that's easy because you just take row 2 and multiply by the reciprocal when it's a fraction, 3 over 23. And we end up with 1, negative 4/3, negative 6, 0, because 3/23 times 0 is 0. That becomes a 1. And 16 times 3 over 23. All right, which would be, what's that, 48 over 23? 48 over 23. Okay, so there we go. So what does that mean now? Well, your final step then. So final step, return to equation form. So if I'm over here, the first equation will be x take away 4/3 y equals negative 6. My second equation is 0x, which means that's not there at all, plus y equals 48 over 23. So therefore, a matrix will spit out a final answer for you. You know that y equals 48 over 23. Now you plug it into the previous equation, 4/3 times, and yeah, this is actually a very ugly example to pick, so let's just keep it simple here. I'm not going to bother going through because you're not going to have one that works out like this. So there you go. So you get your two values. You get your x and y value for your solution. Okay, so you'd end up with therefore, the solution is that ugly mess from above and the 48 over 23. Okay, now we're lucky that the ones that I've got coming up work out a little bit nicer than that. So if you want to just slide back a couple slides then. So when you get a matrix that looks like this one, this is what we call an independent solution. So I went back a couple of slides, independent solution. Okay? So that means there's one answer. In the matrix, if we ended up with our last row of zeros, this is result, and I'll explain why when we do a 3 by 3, or a 3 equation, 3 unknown ones. This is called a dependent solution. Which means that with a dependent solution, there's an infinite number of answers. Or lines are collinear. They're the same line. Okay, and finally, this one, if you think about it, if you would have jumped out and came up with an equation for this, we would have had x plus 2y equals 3, and on the bottom row, we would have had 0x plus 0y equals 5. So what values of x and y would make that true? There's no solution here. So this is what we call an inconsistent system. And in our case here with this system from grade 10, lines are parallel. All right. So let's try running through an example that's 3 by 3 and show that it works out a little bit nicer. So we'll come back to this one a little bit later on. So here's your next example. So step 1, we need to put these 3 equations in matrix form. Now before I get started, I want a 1 in the A11 location. And I notice that the third equation has a 1 starting off. So what I'm going to do is I'm going to pull a switch here. I'm going to switch R1 with our 3. So that means that the third row is going to actually be my first row. So I'll have a 1, a 2, negative 1, and a 3. Then I will have my 2, negative 3, 1, and 0. And finally, negative 3, 8, negative 3, negative 6. All right, so I switched rows because I want to have a 1 here. The second step is to make the following values equal 0. So how am I going to do that? Well, the first row, once I have a 1 in the first location, it never gets changed or touched. So it's going to be the same from now on. Next, how do I make the 2 into a 0? I'm going to take row 2, and I'm going to subtract 2 times row 1, which will mean I'll have a 0. Then I'll have the negative 3, and I'm going to subtract 4, so that's going to give me negative 7. I'm going to have the 1, and it's going to be adding 2, so I'm going to end up with a 3, and the 0, take away 6, gives me negative 6. Now, I also want to make this a 0, so now I'm going to take row 3, and I'm going to subtract, or actually I'm going to add, opposite sign here, 3 times row 1. And what that'll do is it'll make that value a 0. So I'll have negative 3 plus 3 gives me a 0. I'll have 8 plus 6 gives me 14. And negative 3, take away 3, is negative 6. And negative 6 plus 9 is positive 3. All right. Moving along then. My next goal is to make this a 1. So I have my 1, 0, 0, which is the first goal. You need to get 1, 0, 0. Next we need to make it 1, 0, and then a 1. So to make that 7 a 1, I'm going to have to take row 2 and multiply by negative 1/7. So top row, again, it's never going to change for us once we've got a 1 started off. This one's going to be 0, 1, negative 3/7, 6/7. I need to make the next value underneath, the 14, I need to make it equal 0. And this is where you can do 2 things. You can use the original row above it. So I can actually, I have a choice. I can use this row here to do my work, if it works out nice, or I can use this row 2. So you have 2 row 2s to choose from here in order to accomplish your goal. Okay, so you have 2 row 2s to choose from. So you have the first one up above here, and in this case it works out nice because 14 and 7 are multiples of each other. If it didn't work nice, I would go down and use this one because the 1 always works. So I'm just going to take row 3, and I'm going to add 2 times row 2, and when you do that, you get a 0. 14 plus negative 14 is a 0. Negative 6, negative 6 plus 6 is 0, and 3 plus negative 6 is negative 12. So, because I have this right here for a solution, okay, this tells me that I have 0x plus 0y plus 0z equals negative 12. So what that tells me is this particular solution is inconsistent. Inconsistent, no solution. So I'm going to finish up some of the other examples and we'll tie everything back together. But when you get 0, all zeros equal something, it's going to be inconsistent or no solution.